Hi, in this video, as was announced, we're going to deal with logarithmic function. Okay, so look, we now have a function y equals natural f of x, which is equal to natural logarithm of x. And this is the function with which we're going to start, of course, natural logarithm. Then we're going to move on to a logarithm with any base, but this one is actually where we can start quite easily. Okay, and look, this time we're going to use definition, just like we did with product rule, quotient rule, power rule, but this case is slightly more complex than the ones we had before. So actually, it's not enough to calculate limit with x approaching n. We need to do it from the right hand side, and we need to do it from the left side. Okay, let me just stress again that x here needs to be bigger than 0. And I think with this we can actually start. So look, we are looking for derivative, so we are looking for a limit. But now we have case number 1. Let's go case 1. And we have that x approaches n from right hand side. And look, why is this important? Look, we're going to look for derivative, so f prime of n equal to limit now with x approaching n from the right hand side, of course out of the difference quotient, f of x minus f of n over x minus n. Now, what does it mean that x approaches n from right hand side in this case? Well, it means that x is bigger than n. So look, doesn't matter how small the distance between those two, it will always be bigger than 0. So we will always have positive value over here. And look, this is important for us because in the latter steps we will use this inside the logarithm, and inside the logarithm we need to have positive values. Okay, so now we can proceed the way we proceed with any other limit we've calculated here. So first we substitute for general forms the specific form of the function. So we've got f of ln x minus ln n divided by x minus n. Okay, now let's remind ourselves a couple of properties of logarithms. We said that ln a minus ln b is equal to ln a over b. And this is the first property of logarithms that we're going to use over here. So we've got that this is the limit with x approaching n from the right hand side out of natural logarithm of x over n and divided by x minus n. Okay, and I'm going to do here just one more thing. I'm going to take this x minus 1 out of the b in front of the logarithm, right? So we have two separate expressions. Okay, so we've got that this is 1 over x minus n times ln x over n. Okay, and look, at this moment, we need to resort again to some tricks. And here, the trick is going to be introduced an artificial variable. Our artificial variable, we're going to call it m, is going to be defined as n divided by, of course, x minus n. Okay, look, if this is true, then if I'm going to multiply both sides, if I'm going to divide both sides of this equation by n, I'm going to get that m divided by n is equal to 1 over x minus n. Okay, so we've introduced variable m for some reason that I'm going to explain a little bit later. Now, look, what we were able to do. Now, I can change 1 over x minus n into m over n, which is going to turn out to be very useful a little bit later. Okay, now, the second thing we need to deal with is x over n. Now, x over n is the same as x plus 0. And as we learned thus far, 0 can be expressed in various different ways. Right? So, how about my 0 is going to be n, negative minus n, plus n, and we divide it by n. Okay, look, this is simply x minus n over n plus n over n. But n over n is 1. Okay, now let's notice one more thing. Okay, 1 plus. What do we see over here? That m is n divided by x minus n. And what we have here? X minus n divided by n. So this is nothing more than 1 divided by n. Okay, and look, this means that at this moment we have everything we need and to replace the variables we've got over here. So let's now do it. Okay, so here we have now limit with, we're gonna leave in a second. Now look, if I have 1 over x minus n, I can replace it with m over n. And this is times ln x over n. I can replace x over n by 1 plus 1 over n. Okay, now the question is, what do we have over here? Look, let's think, let's now think about this expression first. What do we have over here? We have x minus n. But we know that x approaches n from the right hand side. What does it mean? Look, it means that x is getting closer and closer to n, but because x is bigger than n, this expression is always bigger than 0. Now, because n is a value that we put inside the logarithm, well, it also needs to be bigger than 0. So look, here we have a fraction in which we have 2 positive numbers. Okay, let's think about it further. What is going to happen to the value of n if we divide n by a smaller and smaller and smaller and smaller number? N is going to get, look, if I have any number n, like 3, it can be 1 billion, but it doesn't really matter. If I divide it by 0.00001, right, I'm going to get that this is 3 times 3 times 0, 0, 0, 0, 0, 0. Right? So by dividing 3 by a smaller and smaller number, I'm getting a bigger and bigger and bigger number. Okay, so look, what does this implied to us? It means that as x is getting closer to n, m is going for infinity. Okay, so now let me carry on a little bit lower here. And let's figure out what else can we do with the expression that we've got over there, right? Look, I hope you remember another rule about logarithms. We said that ln a to the power of b is the same as b times ln a. Okay, so look, we could take this whole thing and put it over here, but this is not what we want. Because look, m times n, m over n can be written as 1 over n times m, right? So what I have here is that I have expression m times 1 over n. So what I can do is I can just take m out of here and put it over here. So I can limit with m approaching infinity out of 1 over n times times ln 1 plus 1 over m to the power of m. Okay, now look, as x approaches n, of course 1 over n stays exactly the same as it is, because we are already at n in this case. So the important thing is, what is this expression? Joke. Have we seen this expression somewhere before? Okay. I hope, if you don't remember, right after seeing this part of the video, you will go back to video number 1. In video number 1, we were talking about number e. And number e is what? Is a limit with m approaching infinity out of 1 plus 1 over m to the power of m. Right? I was demonstrating this to you using the example with the compounding interest there. And again, if you don't remember it, I recommend that you go back to the video number 1, see it again. Now, so, as it turns out, with m approaching infinity, this part turns into 1 over n, right? And this is turning to e. So, how much is ln e? To which power I need to take e in order to get e? Of course, this is equal to exactly 1. So the outcome we get is 1 over n. Okay. Now, we've done half the work. And by half the work, of course, I mean here that we've calculated the right-hand side limit. But look, limit exists if and only if right-hand side limit and left-hand side limit exist. So, what we need to do now is to consider the case 2, where we've got x approaching n from the left side. So, again, we calculate f prime of n as a limit with x approaching n, this time from the left-hand side, out of f of x minus f of n over x minus n. Okay, and look, now x is smaller than n. So x is getting closer and closer to n, but it's always a little bit lower than n. What does it mean? That if I'm going to take x, which is lower than n, and subtract n, I'm going to get a number that is negative. And let's just say I don't want to have it. What can I do? I want to have, what am I saying now is that I want to have here a positive number. Well, I can take minus out of this expression, right? Change the order over here. And if I'm going to change the order of those two, of course, I need to also change the order of these two, because only then, look, you can imagine it like, again, multiplying this by 1. But this time, our 1 is negative 1 divided by negative 1. Right? Again, I'm multiplying this expression by 1. Nothing changes. The only thing that will change is that they both gonna reverse orders. Okay, so over here, I'm getting that this is a limit with x approaching n from the left-hand side out of f of n minus f of x divided by n minus x. Okay, and then we carry on. Okay, what are the two things I can do over here? Look, again, I can use the property of logarithms, and I can do the same trick I did before. So I'm going to take the denominator out in front of logarithmic. Oh, I'm sorry. Before we do it, I skipped that step. Let's change those into ln's, right? Because this is what the thing we need to do first. So here we will have ln n minus ln x over n minus x. And now in this step, I'm going to use the property of logarithms and take this denominator out. So I'm getting this limit with x approaching n from the left-hand side over 1 minus n over n minus x times natural logarithm out of n over x. And look, again we stumble upon very similar step. Now, what we need to do is to introduce another variable, auxiliary variable, and this one is going to be me. This is Greek letter me. You're going to be using it to denote average value in your statistics class, so please get used to it. And how am I going to define me? Me is going to be x over n minus x. Okay, so now what is going to happen later? Of course, I need to go through more or less the same steps I've taken over here. So now, look, I'm going to divide both sides here by x. And I'm going to get that me over x is equal to 1 over n minus x. Okay, then what do we need to do? We need to deal with the expression we've got over here, n over x. And again, we're going to use the very same trick. So I'm going to write it as n minus x plus x divided by x, which will give us 1 out of these two, plus n minus x over x. And again, we see that that me is defined as x over n minus x, 1 plus n minus x over x. So if we have n minus x over x, we just simply have 1 plus 1 over me. Okay, so again, what we can do is start substituting. So again, I'm going to keep the limit where how we're going to replace this is going to turn out in a second. And now, instead of 1 over n minus x, I can write me over x. And instead of n over x, I can write 1 plus 1 over me. Okay, now, what is going to happen over here? Look, when x is approaching n from the left-hand side, we said that this expression is negative. And I told you that what I wanted to do is to take minus out. This is why we rearrange the order. So here I have n minus x. So look, as n minus x is going to is getting smaller and smaller and smaller, because n is bigger than nx, this expression is still positive. And look, the same thing can be said about x. Because it is in the domain of natural logarithm, it must be positive. So again, I divide a given number by a smaller and smaller number. As a result, I'm getting a bigger and bigger number. So as x approaches n from the left-hand side, me is approaching infinity. And look, this is why, actually, in this case, we needed to have a limit evaluated from the left-hand side and right-hand side. Because look, it depends all on this expression. I cannot tell whether m would be going for infinity or negative infinity without knowing whether n is bigger than x. So whether x is approaching n from the right-hand side or from the left-hand side. Okay, and look, we already know how to deal with this expression, right? This is not very problematic. Now we know that this is going to be the limit with me approaching infinity out of 1 over x times ln 1 plus 1 over me. Okay, that was easy. Now, and of course to the power of me. I'm sorry. Now, what is going to happen? Look, as x approaches n, 1 over x turns into 1 over n. Now, as me approaches infinity, this expression turns into e. ln e is 1, so we've got 1 over n. So look, limit evaluated from left-hand side and limit evaluated from right-hand side and from left side are giving us exactly the same expression, a finite number, right? And if left side limit and right side limit are equal to one another, it means that the limit exists and is equal to 1 over n. So, by that, we have obtained the logarithmic function rule. And the rule here is very, very simple, as you see. Now that I can replace n with any value of x, I can write that derivative of ln x is simply equal to 1 over x. Okay, but you might say, well, that was really a lot of trouble to get such a simple result, and basically that this result is associated with just one very, very specific function. But look, we can easily generalize this rule to different cases. For example, what is derivative of ln x squared? Well, we will have a special rule for more complex cases like that. But look, I can simply write that this is derivative of 2 ln x. And look, I could deal with this using product rule, but derivative of a constant is 0. So look, we're going to get that this is simply 2 times 1 over x, which means that this is 2 over x. So in general, we will get that derivative of ln to some constant power k, right, is going to be equal to k over x. Now, what if we have something, how to say, touching x, so multiplied by x. So now, look, if I have derivative of ln, let's just say 3x, how much is this going to be? Well, look, this is the same as derivative of ln 3 plus derivative of ln x, right? Now, what is derivative of a constant? 0. So this is 1 over x. And finally, out of that, we are getting another rule. The derivative of ln cx is equal to 1 over x. And look, if I'm going to now take and combine this rule with this rule, what am I going to get? Well, now I'm going to get that if I'm going to take the derivative out of natural logarithm out of cx squared, this is going to be, cxk, of course, we want more general. Look, again, we could do the same trick. This can be rewritten, ln cxk can be rewritten as ln c plus k ln x. So again, what we're gonna get out of it, that this is k over x. Okay, of course, we might have examples of way more complicated functions inside of logarithms. But with this problem, we're gonna deal a little bit later. Okay, thank you for your attention and see you in the next video.